So without further ado, with me, I have four of our young alumni. And so I'm going to, so how this is going to work is I'm going to introduce these, say a few short things about our alumni, and then they will then take over and give you a little bit more information about themselves. And then we will be very happy to take Q&A from you. So if you are listening to us out there, do feel free to ask questions in the Q&A session. Now, so as I explained, this is our alumni session, and which will be followed by our industry session. So, you know, questions of curriculum and, you know, when do I need to accept things and do I need to do a project? Those questions, we can take them, but we will do them in the background. My colleagues are here in the background to help answer some of those questions. So let's start. My name, I forgot to introduce myself. My name is Christina Lim. I am a professor with the NUS Mechanical Engineering Department. I think all our alumni who are online were probably taught by me at some stage. So I'm just going to start with the slide you saw just now. So I'm going to just say a few words, starting with Nicholas. So Nicholas is a person with a dream job. He is working for Dyson, and he's the engineering manager of technology development in personal care. In short, that kind of, I think, translates to hair dryers and hair curlers, which actually is very important. I bought a hair dryer myself from Dyson the day it was launched in Singapore. So anyway, you know, Dyson's headquarters is now located in global headquarters is now in Singapore. They're going to move into St. James Power Station soon. And you might know that they are actually looking at hiring local engineers and expanding the team. So, you know, as an engineer with Dyson, Nicholas was able to work in the Dyson's main campus in the UK at Malmesbury in the southwest of England for a while, just recently. And while he was there, you know, he helped to collaborate with UK engineers and, you know, bridge this global collaboration between the Dyson engineers. So he's going to tell you a lot more about his experiences in Dyson later on. Now, the second person I want to introduce is Lingman. So she is now a regional associate partner business manager in VMware, which a lot of you might have heard about. VMware is actually a cloud computing company. So, you know, if you want to hear about how ME graduates can end up in a field that you might not think about, like in cloud computing, I think, you know, Lingman will be very happy to answer your questions. So while she was with us, Lingman was very, very active in CCAs, and she, soon after her graduation, she even became the president of our Engineering Alumni Singapore, which is a society for Singapore graduates from engineering schools. So she was the president for 2 years, from 2018 to 2020. And again, while she was with us, she participated in our NUS Overseas Colleges program in Beijing. So she was one of the earlier participants in our Beijing program. And I'm sure that she actually took a lot away from that program. So, you know, if you want to know about how do you balance student life with your studies, I think Lingman will be very able to answer that. So, then another graduate of our NOC Overseas Colleges, hang on, let me just pull up the information. So our next panelist, Kittin, was also a graduate of our NOC program, but he went for a year-long program in Silicon Valley. So as you know, after graduation, one of the jobs he worked in recently was for GovTech, where he was looking at how do you program the Boston Dynamics Spot dog robot for autonomous surveillance. You might have heard about Spot when he was deployed, I think there were a few of them, when they were deployed to surveil parks in Singapore during circuit breaker last year. So right now, Kittin is a robotics engineer in a startup and is also pursuing a part-time master's back with us in ME at NUS. So he would be the perfect person if you want to hear about how do you juggle studies and work, after graduation. So last but not least, we see Grace, who appears to be in a car. So Grace is very well known to us. She was very involved in designing and building autonomous underwater vehicles during her time with us. And she was instrumental in starting our Bumblebee project, which sees students designing, building UAVs and participating in overseas competitions. So after working for a UK MNC for a while, where she was looking at subsea equipment, she started BX, which is essentially a commercialization of our marine robotics technology, and that stems from her love of UAVs, which she developed during her Bumblebee years with us. So that rounds up our panelists, and I'm just going to turn the time over to them now, and if they could introduce a little bit about themselves in the order that I've introduced them. So starting with Nicholas, our panelists, by the way, can also share some slides if you wish to. So Nicholas, can I turn the time over to you?
Yeah, okay, thanks, Prof. Lim. Can you hear me?
Yes, we can.
So I'll share my own slides then, just give me a minute to pull it up. You should be able to see my screen now.
Yes, we can see your screen. Yep.
Okay. Yeah, so hi, morning everyone. My name is Nicholas and I work for Dyson. So I'm just going to share a bit about myself in the next 3 to 5 minutes. So a bit of background about myself. I studied mechanical engineering in NUS starting in 2008, graduated in 2012. So I've been working with Dyson for about close to 9 years now. So I'm not as young as Prof. Lin says to be. My FYP was in cooling via jet impingement, and I worked with a professor in ME called Prof. Chris. And I joined Dyson in 2012, where I joined the acoustic team, which is quite an interesting team for me to join because when I was studying in NUS, I didn't take any modules that was related to acoustics or even vibration. So I'll share a bit about how my career has progressed since then. I started as a graduate, and then after that, I went on to doing a bit of integrating motors into our current fans, our purifiers. And then as Prof mentioned, I went for a short stint in the UK for about 3 to 4 months, where I worked with the upstream research teams to try and make sure that the products that comes out from research are manufacturable for consumers and for the kind of products that you see, for example, the Sonic. The last thing I did before becoming a manager was I was literally thrown into the deep end on one of these big issues that we saw on one of our fans. So my boss decided to make me a task force leader and what I had to do was to basically pull together engineers from different teams And oh, there's a bit of noise. Is that from me or?
Well, fine, Nicholas. Please go ahead.
Okay. Yeah. So in the last stint as a task force leader, I had to basically pull together engineers from different departments, different backgrounds, and I had to solve quite a big technical challenge. I think of it as FYP times 100 kind of complexity. And FYP you're given a year, but in the real life scenario, I was given a month. So that was quite an interesting experience for me. So right now I work for the personal care category, and you should have seen some of our latest launches like the Supersonic, the Curler, and the Dyson Corel. So those are the kind of products that I currently work on right now. Some of the engineering disciplines that I have to delve into since graduating are these 8. So materials, which is what I learned from Prof. Lim, understanding how when you drop a product, how a crack propagates, and actually not just how it propagates, but then how do you stop it, so that when you spend $600 on a hairdryer, it doesn't break that easily. And various other things that I won't say in all, but the next thing that was really, really interesting for me was mechanistics, because mechanistics is all about trying to quantify what users perceive into an engineering metric. So that's not something that I learned in school, but with the foundation I got in NUS, I was able to learn some of the basic skills needed for this specific subject. Because in acoustics, sound is very subjective to users. So how do you define a quantifiable metric that you can use to kind of test hundreds of products that come out from the production line? So a bit about Dyson, the company that I work for. If you don't know, our founder is Sir James Dyson. I'm sure most of you should have seen his recent news about him moving back to the UK. So that's who he is. And his first philosophy was he wanted to create problems. He wanted to create solutions for problems that he himself experienced, like a vacuum cleaner. And he also felt that some of the motors in the markets was really big and chunky. So the kind of philosophy that we have in Dyson is we must solve problems that people ignore, and we just want to do it first. And this is some of the products that we have launched since dealing with the backless vacuum cleaner. We had a short stint of doing the laundry, but I think we stopped that for now. So around when I joined, which was 2012, I started to work on fans and the hand dryers, which then I think after a few years was when we started to go into things like robotics, lightings, and cord freeze, purifiers, and personal care. So just some numbers about the company itself. We have about 100 million people who own Dyson products, about 6,000 engineers and scientists, both in UK and in Singapore, and a portion of them in Malaysia as well. In Dyson UK, we have this thing called the Dyson Institute, where we currently have 150 undergraduate engineers. And we have offices in about 84 markets, 10,000 patents. And currently, we have about 1 Dyson motor or machine that's being manufactured every 2 seconds as we try to go into the industry 4.0. So where we are and where are all our research centers in the 84 markets. So Singapore is one of it, and we have some in Shanghai and a new one in Philippines, and 2 in UK. Harlavington was meant to be for our EV, but now we have transformed that for newer categories, which I can't really share because of the confidentiality of them. So Singapore Tech Center is where I am, and it's where I will sit for now until things change. We moved there recently about 3 years ago, and I think if you come to Dyson for an internship, you can see what are some of the cool things that we have in our labs. So we started in Singapore by actually manufacturing the digital motor that you can see in all of our cord-free products and our hair care. And we slowly ventured then into developing the actual products in Singapore. And now we're starting to do a bit of research as well. So our footprint in Singapore is starting to grow from when it first started 10, 15 years ago. And for me, that's quite important because obviously it means job security, but at the same time, it means that there's opportunities to learn and grow as an engineer, even though I'm still a manager. So the role of Singapore for Dyson is that we are starting to do things like robotics, machine learning. This beautiful chamber you see right here is actually owned by me, and this is where we actually test the acoustics of our products using an IC standard chamber. And this is actually our manufacturing line. It's somewhere in the west. I wouldn't say in Tuas, maybe more towards Jurong side. So not that far from where we are in STC. And you can see that we don't really have many operators in this production line because everything is actually automated using precision engineering for assembly of the very, very small impellers and rotors. So that's the role of Dyson. That's the role of Singapore in Dyson as a country to the business. And moving forward, in the news, our CEO Roland recently announced that there will be 2.75 billion pounds invested in Singapore over the next 5 years. What that means to me, it just means that I have a job for the next 5 years at least. But it also means that we are not only we are constantly desiring to grow as a company in Singapore, not just grow in terms of our size, but also grow in terms of the kind of technologies we want to create and invent for the world, I guess. So that's the end of my sharing.
Thanks, Nicholas. So we'll take questions later. I know that's already a question for you. So let's move on to Lingman.
Thanks, Prof. Lee. Yeah, sure. So hi everyone. I didn't prepare any slides, so I will just speak. I'm Lingman. I graduated 4 years ago in 2017. So since then, for the past 4 years, I've been working in VMware. So VMware is a software company that provides virtualization and cloud computing to over 90% of the Fortune 1000 companies. So we are a 10 billion business-to-business company that has over 500,000 customers. So do you know that NUS is also our customer? So NUS uses the VMware virtual desktop. So if you go to the NUS computer labs and then you power on the desktops, you realize that it's being powered on by this software called Horizon. So I'll explain more, especially during COVID, right? Companies need to embrace remote working. So NUS staff, NUS students need to use virtual desktops so that they can access the NUS apps, the NUS secure data from anywhere and from any device at any time. So virtual desktop comes with a standard list of software that lets staff continue doing their work from any device, although they are interrupted. Also, interestingly, I recall when I was still in NUS, when I went into the NUS Com Lab to use the SolidWorks for our computer-aided design, I realized that it was being powered on by VMware Horizon. So, meaning to say, because certain software like SolidWorks need to be only used on Windows, and they need to be available to different students at different times of the day. So NUS uses the Horizon software to make it more cost-effective and simpler for engineering students or even the architecture students to use such computer-aided design software. And then back to my job in VMware. So I am a current partner business manager. So what I do is work with VMware's business partners, such as HPE, which is Hewlett Packard Enterprise, and Lenovo. So these partners are what we call as the OEM partners, original equipment manufacturer. So they are the ones who sell servers. So my job is to make sure that they sell our software together with their servers. so that it comes to the customer as an entire package. So my job is to help these OEM partners grow their revenue by increasing their sell-through of VMware solutions. So my job is to work with them, ask their sales reps, their pre-sales, whether they are enabled, do they understand how VMware solutions are, do they know how to tell the customers how VMware solution works for the customers. So we actually offer training for the partners, and also we do joint business plans with the partners to guide them into how they can increase their profits and how they can always look at maintaining a very good joint relationship together. Also, some activities that I do is working together with these partners to do customer workshops. So we will get like speakers from both the partner and from VMware to talk about a specific product. It could be, as I mentioned, the virtual desktops, especially during COVID, or just about how to build a private cloud, or also how to build a hybrid cloud together with our partners in Amazon Web Services, Google Cloud providers. So we offer such joint solutions with public cloud vendors. So we work with partners to come out with such topics that interest our customers, and then also drive effective marketing campaigns to reach out to more customers. So my path is a bit different from the general engineering path, but later feel free to ask me questions. Yeah, thank you.
Thanks so much, Lingman. So without further ado, can we invite Kittin to talk a little bit about your jobs and introduce something about yourself?
Okay, sure. Hi, everyone. I'm Kittin. I graduated from mechanical engineering back in 2019. I actually went into mechanical engineering to do aerospace engineering, and but I switched to robotics in the final year. So in third year, I went to NUS Overseas College in Silicon Valley and also attended classes at Stanford. I interned at a startup specializing in flexible touchscreen display. So back then it was really cool and it was kind of eye-opening. And my background in mechanical engineering has actually helped to, allow me to do a lot of analysis that relates to stress, strain when it comes to flexibility of the material. Then when I came back to Singapore in year 4, I didn't have to do a final year project because I could just map the module directly from NUS Overseas College. So what I did was, and back then I was very interested in robotics. So what I did was I just went up to Prof. Marcelo and asked him whether I could do any project with him on robotics. And that's how I started my career in robotics, I would say. So in year 4, I really picked up a lot of robotics in the lab, just helping out in some projects. Back then I helped in autonomous scooter. And upon graduation, I was fortunate enough to be recruited by him to be a research engineer in his lab. And that's when I worked on autonomous system for a mobile robot. And I also work very closely with many big companies, for example, Micron, where I helped to develop autonomous golf buggy that would be transporting people within the facility itself. I also work very closely with NVIDIA on autonomous solution. And after working in NUS for about 1.5 years, I was recruited by GovTech to work on a really cool project, which is to develop autonomous system for Boston Dynamics Spot. So when you see Boston Dynamics Spot, you can see that, okay, you can move really fast, it can move really well, but the autonomous system is actually not product ready. So what we did was we developed our own autonomous system on top of that, as well as giving it other capability. So I don't have any slides to show, but I just have one single video that that sums up what we did at GovTech. So what you see in the screen here is our command and conquer controller to control autonomous system. And this system was actually running at Sun Yat-sen Nanyang Memorial Hall in Balestier in Singapore, I think end of last year. So whatever you see here is actually all developed in-house. And whatever you see here, the data is live streamed through 4G. And it has its own, we have developed two-tier obstacle avoidance capability on it. And the robot is able to follow a path accordingly and able to avoid anything along the way. And what we did was we developed this and we developed on other video analytics solution on top of this so that it can do other things like surveillance and safe distancing enforcement. And that's, I work together with a team of about 6 experienced engineers, but only 2 of us work on autonomous system of whatever you see here. And right now I am in a stealth startup working on robotics as well, but I cannot share much right now. I can only share sometime after 25th May. Yeah, so that's all I have.
Thanks, Kittin, and good luck with your stealth startup. At first, I thought you were working on stealth technology, but then I realized it's a hush-hush. It's a hush-hush thing. So anyway, last but certainly not the least, Grace, who is a frequent speaker at our events, please take it away.
Hi, good morning, everybody. Yeah, my name is Grace. I am the CEO of PX, a spin-off from NUS. I studied in NUS as a mechanical engineer from 2009 to 2013, 2014. So I've been in the university for 5. I extended my graduation because I went for the 1-year NUS Overseas College program in Beijing. And after I came back, I was very excited about building new stuff. And at that point in time, Singapore was trying to groom more engineers that understood water systems. So there was a competition here in Singapore, and we started participating in it to get experience in building stuff on our own, because yeah, we didn't really have that much project work in the past. So with that project, we were able to fly overseas to participate in international competitions where these AUVs are doing tasks that are today too dangerous or mundane for humans to conduct. So like, for example, instead of sending a human diver to inspect underwater structures in the deep sea, you can now send vehicles like AUVs to conduct the inspection and carry out the job more efficiently and safely. So in the past few years, I had been working in this area, and I felt that my mechanical engineering education was very useful, because when you are working with vehicles, and especially when you are designing and making them, you need to understand how to make them better. And making them better relies a lot on the hardware aspects, and that's what we learned past, all the computational fluid dynamics, how we deal with the different machines, the motors, and working in a multidisciplinary team, because that's what we did at the student project team over here. They see all the students in the yellow shirt at the bottom. This is them participating in the competition in Hawaii. On the left is the competition that they typically participate in San Diego. So that's the Pacific Ocean behind that. And it's really exciting to see the work that we are doing being deployed in this kind of real world scenarios. So there was a question I saw about like ME being hard or whatever. So I can tell you that my CAP, which is this like academic grade that you have within NUS, I didn't have a very good CAP. I'm not a very good student, but I think what's important in the university, like in the time that you have within the university, is really to learn, study not for the sake of just the results, but really because you want to learn and have try to find opportunities to apply what you learn. By attending industry events like this, and also a lot of these when you actually join NUS itself, you will be able to see how the knowledge that you pick up within the classes can help you in your future jobs as well. And most importantly, I tell all the students that join Bumblebee every year, is one important thing that you should, kind of look at in university and also after graduation, is to think about what are the great things that you want to do with your lives, with the skills that you pick up. to dare mighty things and have big dreams and pursue them independent of what other people think you can or cannot do. Yeah. So if you're interested to find out more about the student project team here, this is the website, and you can find them on Facebook as well. Yeah, thanks.
Thanks so much, Grace. So picking up from what Grace said and looking through the questions, I think a lot of people have questions for Nicholas because, you know, he has been, he's a Dyson engineer for a number of years. So I think maybe to kind of summarize some of the questions that they asked and relating to what Grace just said, you know, I think for prospective students, one of the recurring things they hear about NUS engineering is somehow we are very theoretical. And so I think along those lines, what Nicholas, so, you know, did you think your undergraduate education was useful in your job? And, you know, because you have done this for a long time, and do you think that, you know, the other things that NUS may have helped cultivated, like, you know, NOC programs and so on, actually help, would give our students the qualities that Dyson would be looking for?
Okay, so to answer the first question, was NUS very theoretical? I would say yes and no, because in the first 2 years of my NUS education life, it was quite theoretical, and that is very much needed because I think in mechanical engineering, it can be as broad as you want it to be. And so you will need to have a very strong foundation to be able to pursue maybe things that are a bit more advanced, but still in the realm of mechanical engineering. So while yes, it was theoretical, but I think that kind of theory is needed to be able to apply the knowledge as what Grace has mentioned in real world scenarios. One of the things that I'm currently learning by myself, and this is like 9 years in the job, is what I call aeroacoustics. So as all of you know, Dyson products always involves air, and as an acoustic engineer, to make it quieter, it's not easy because you want high flow rate and high velocity, but that usually generates sound, very, very loud sound, if you think of F1 cars. So as I read up about aeroacoustics, you start to see all these weird and complex partial differential equations, which I still don't understand. But if I never had the foundation of what PDE is or an ODE is, I'll never be able to understand what the text or what the literature is trying to explain. So to me, yes and no. NUS is theoretical, but I think there's a good reason for it. I think in my third and fourth year, when I was able to go for overseas exchange and do projects with, I did a joint project with some students from Beijing. I think that was when I was able to actually apply some of the lessons and knowledge from the modules that I picked up, namely things like fluid mechanics, thermodynamics, mechanics, and materials. So in the last years, I felt that it was less theoretical, but more application-based kind of learning. What's the second question again?
Okay, so you might have heard that, you know, NUS is for engineering students, we're introducing a whole host of common curriculum, and we are, you know, teaching things like systems thinking, project management, artificial intelligence, design thinking for engineering students. So that's different from what you did. So do you think that, you know, these kind of modules would help prospective students, you know, would these kind of knowledge be useful if a student were trying to get a job in Dyson? So that relates to, you know, what kind of things is Dyson looking for in an engineer that they hire?
So I think if you saw my slide earlier on about with the photo of James Dyson holding a big and small motor, his philosophy is that we want to solve problems that people ignore, and we want to do it first, because quite frankly, the only way we can get the resources to solve problems first is if we have investments, and to put it very bluntly, that comes from profits that we gain from consumer buying our products and the kind of market share that we get for our products. So in order to well, firstly, solve problems. I think one of the things that I look out for is a graduate's ability and how they respond in a situation where they don't know something or they didn't learn from school. One of the questions that I like to throw out to graduates is, I would draw a simple airflow and this changes, so you cannot use this if you get interviewed with me, and see how they respond to what happens to the flow after a specific change in a cross section. So I will then question and poke and ask, why do you think it's this way? Are you sure? And if they're able to defend and convince me that what they say is true with engineering logic, then I think that's a good skill set. Because a lot of the times in Dyson, it's all about trying to convince people in other departments about why you think this is the right design and not the other design. So working with others is something that's very important as well. And I think that's where systems thinking come about. So I studied mechanical engineering, but right now you can see that there are 8 types of discipline that I have to think through in my day-to-day work, even as a manager. So having that breadth of engineering knowledge enables us to work more collaboratively, because as Dyson grows, you have more and more engineers with various disciplines, and if you don't speak the same language, sometimes it's very inefficient in product development, and that will not allow us to be first in solving that problem, or to put it in product development terms, we won't be able to launch first, and therefore not get the kind of market share that we need to invest, £2 billion into Singapore. I hope I answered the question.
Yes, thanks, Nicholas. Let's move on to another question, this time for Lingman, because I think, as you've said, Lingman, your job right now is quite different. Particularly if I'm looking at Nicholas' job, it's quite different. So the question is, your job seems to be very computer science related. How do you feel? How did your ME engineer education come in? Did it come in at all, or should people be all studying computer science instead?
Okay, I got that. Okay, so I would say that I really liked, I really was happy that I did a degree in mechanical engineering, because that gave me the mindset to be able to understand technical concepts faster. So for us, we do have some, for new employees that join the company, we do have some onboarding modules for you to pick up the concepts and read about it at your own pace. So it helps to, if you are strong technically and you went through the ME program, you will understand that to do well and to be able to solve engineering problems, you have to break down the problems and then make sure that you understand. And even if you don't understand, you can always consult other peers or professors for help. So I use the same technique when I started doing my job. So I learned all the materials that they gave me, and then when I don't understand, I went to ask like other seniors or other colleagues in the company who are specialized in certain fields, and make sure I understand what the company product is about before I'm confident enough to like talk about it to other people who don't even know about VMware. So the other interesting thing that I would say is that ME actually covers a broad range of engineering aspects. So we learn things like programming in year 1. We also learn computer-aided designing. We also learn about manufacturing processes. So all these concepts caught out to me, especially when I actually joined as a common engineering student in year 1. So I was like deciding, which one should I go? But after I did research and check on the modules, and I realized that some of them are so interesting and even can be applied in our daily lives. Like after I graduate, I learned about the refrigeration and aircon cycles, and I felt that was quite interesting to our daily lives. So I would say it's your mindset that is more important. As long as you tell yourself that you are willing to put in the effort to understand a very difficult concept, or to ask people for help when you need, and to be open to working with your peers to solve a common problem together, it shouldn't be a problem.
Thanks, Lingman. So I see a couple of questions actually on robotics. So maybe we can ask Kittin, so hang on, I'm just trying to find out where it is. Oh, it disappeared. So anyway, Kittin, you have worked in a number of roles since graduation, because I think you were working with one of our professors for a while, and then you went to GovTech, and now you're doing a startup, and you've always been in robotics. So can you share maybe a little with us about whether your ME training, how is that relevant to the field of robotics maybe? And if students are and given the outlook, do you think robotics, an ME degree will be useful in solving the problems of tomorrow with robotics?
Yes, I think for ME is quite important, because robotics is not just only about programming, right? Many people have a misconception of if you want to learn how to code, you go into CS. But actually, I don't think that's true, because in engineering, we actually do code as well. And in mechanical engineering, for me, I did a lot. Back then, there was no robotics specialization. So I did a lot of control modules, or that involved quite a lot of math. And that requires me to do some programming as well. So I think ME has laid this kind of foundation in terms of control theory, mathematics, and that allows me to after I have picked up my coding, I can then proceed on to develop an autonomous system. But also robotics is not just only about programming, right? Robotics also has hardware. And with my background in mechanical engineering, I would say that I'm able to build the entire robot on my own, and then I can program it and make it go autonomously on its own. So I would say that the knowledge in hardware engineering or mechanical or electrical are very critical in robotics development, because robotics is a very complex system, and certain things affect another. And if you don't have a very good overview or very good understanding of every component on the robot, you may not really know how to solve them. But if you know, then you make your troubleshooting and development a whole lot faster. Yeah, so that's one. And I also see some questions for me. One is about asking me how I ask a professor for a project. So in year 4, I was taking this class called Robotics Control. And back then I had no background in robotics. So the professor who was teaching that module was Prof. Marcelo. So one day after taking his class, I just went up to him and asked, "Hi, Prof, I'm pretty free. I don't have final year project. Can I help you in some of the robotics project?" Then that's when it first started. So I think for this, you just need to first know what you want to do, what kind of area and field you want to go in. And secondly, you find a professor and just ask them. And typically they will be very much happy to take you in and ask you to help out in project in one way or another.
Thanks so much, Kittin. So I want to save some time for Grace to answer your question. So it starts with a compliment. You're very inspiring. And actually, we all know, we in the ME department know Grace over the years, and she's actually giving back a lot to our programs as well, in terms of offering our students opportunities to design and build. So Grace, just want to ask you, what you worked for a UK MNC. That's a safe job. People, that's the kind of jobs that students and parents in particular, parents want their kids to have a safe job in an MNC. So, now that you're doing a startup, can you talk a little bit about, your decision-making process? Why did you give up your job in an MNC? And, and in terms of, maybe if you look back at your studies, now that you are contributing to, building our next generation of engineers, how do you think about the support system in NUS engineering for students?
So maybe let me start with the second question first on the support that NUS provides. I think this is it has increased dramatically over the past few years. I think the university is very supportive of student projects, of students wanting to create their own projects right now, and giving us resources in terms of professor guidance, space, industry events, interactions to deal with all this, to the extent I feel like now it's a lot of things. You know, a student has so many events that they can go for right now within the university that they can help to guide their career choices. And it's not just within the department itself. NUS Enterprise now helps to spin off technology from the university. The halls and university like Newtown, they provide accommodation and also modules that you can take within the place that you stay that can be mapped back to your academic curriculum. So it's like work and it's like living and studying at the same place and interacting, building up your interpersonal skills with the people that you stay with. So this is also another aspect of NUS life. I think if you really explore all these options, your university life will be very exciting and colorful. So I think every student that comes to NUS really should tap on this kind of opportunities and explore more, because it's really very fun. But study hard as well. Then about why I decided to leave the MNC job to build a startup. I think we have been thinking, my team right now, we have 8 people within the startup. 70% are from NUS and 30% are external hires. And we just have a great team now that have a good skill set of commercializing new technology. So our vision within the startup is really to become a trailblazer for underwater inspections and interventions, which means that being a trailblazer means that you are pioneering something new. And pioneering something new means that there's no incumbents, there's no, we are all on the same playing field. So that's the exciting part I like about it. We are all competing on the same ground. We are all new to this area. So in that sense, MNC and a startup is no different. In fact, a startup has more flexibility and nimbleness to deal with challenges and look at the problems in various angles. So for me, I think it's really the team that after so many years, we've been building up this team. We think that's the right time. And also, this comes at a time where university is also trying to have a proper structure of commercializing our research. So we now have the Graduate Research Innovation Program that allows NUS research to be commercialized by the startups. So this provides a good framework for people that want to do it, to understand how to do it. And they will provide you with financial support, and also non-financial assistance in doing this translation. I think it's really important and really exciting for me to see the work and the R&D that our scientists are doing is able to go out to the real world and make an impact, even if the company may be small at the beginning. Yeah.
Thanks, Grace. We are actually coming to the end of our session, but I have one last question that I would actually like to ask Lingman, because she was so active in CCAs in NUS while she was here. So I think many students want to know about student life, you know, the kinds of activities and how do you balance your work, you know, work-life, about work-life balance, and also relatedly, how do you feel the support structure is, you know, from the department, from your lecturers, from your peers? If you lived in a hall, you know, how is that? So maybe Lingman can help us to answer that question as the last question of today.
Yeah. Can you hear me? Sorry, my internet is having a bit of problem.
Ooh, we can hear you, but your screen seems to be frozen, but maybe you can just go ahead and talk.
Yeah, so I remember when I was in NUS, there are always emails about opportunities, whether you want to help out as a student day ambassador, or you want to apply for NOC, or you want to apply for short-term exchange programs that were about
Oops, we
See
see.
which opportunities you like. Yeah.
Sorry, let me just go ahead. I think there was a little hiccup.
Yeah, so just keep an eye on what are the opportunities that interest you, and go ahead and apply for it. Like don't think too much about whether I can get it or not. Just go ahead and apply, and if it comes, just take it on and enjoy the experience, because you will find that it will help you later in terms of your exposure. And how I balance my student life, I think, like, I just set very concrete timelines for myself. Like especially in the ME course, we do have quite a fair bit of project work sometimes. So I will find like friends that I know are as committed as I am to work on the same project together, and form study groups. That's very important. You go through tutorials and exam questions and concepts together, and spark off a healthy discussion to make sure that you understand everything. Find professors for consultations if you need to. Basically make sure that you don't fall behind too far, because it'll be very hard for you to catch up later. So whenever after a lecture, try as much as you can to look through the lecture content and do the tutorial questions. Then set aside some time to, I don't know, maybe walk over to Utah and like explore the events that are happening, so that you can at least have a relaxation time after your studies. That was what I did. Like, just make friends around the hall that I stayed in, join activities that I'm interested in. Then turns out I spent 6 months in China, and after that I managed to map some of my activities over. So everything worked out fine for me in the end. I just came back to do my FYP. And talking about FYP, you can also choose the FYP topic that interests you. We have a wide range of topics and specializations. So you can talk to the professor, like Kittin mentioned, and ask them, oh, can I do a research on this specific topic that I'm interested in? So this is something that I'm really grateful that NUS Engineering has helped me so much in my current job also. Like, I'm more open to trying new things. I also managed to remember what I learned to apply to my daily life. So, I mean, if you have more questions, yeah, feel free to reach out. We'll answer them.
Thanks so much, Lingman. Sorry, your video seems to have frozen, but we heard you fine. So because we are running out of time and we need to start the next session with our industry speakers at 11, I want to thank all my panelists who spent the last hour with us and shared your really valuable perspectives with our attendees out there. And I hope, so I just want to thank our panelists very much. I also want to thank our attendees for asking the questions and being part of this. So if you guys out there who are participants and want to stay and hear about and ask questions of our industry speakers who are also our alumni, but from further back, do hang out with us. We'll be back at 11. So thank you very much, everybody. See you in a while again. Bye. Okay, good morning, everyone. Hi. So welcome to a session with NUS Mechanical Engineering, where we have some of our alumni who have been working in industry for a while, and they will share with our attendees, prospective students and parents, about their experiences in industry, and to answer, any questions that you might have for us. So to begin with, my name is Christina Lim. I am an associate professor with NUS Mechanical Engineering, and so what we're going to do today is I'm going to give a very short introduction about our panelists, which you can see here. I will go in the order that they are listed in the slide that you see before you, and then I will turn the time over to them to say a few words about themselves and to introduce themselves. They may share a slide or not, but it would be a short introduction, and then afterwards we will get to the Q&A. So if you have just joined us, there is a Q&A button there where you can ask your questions, and you are also free to ask questions on curriculum, but of course our industry speakers won't be able to answer that, but I do have my team of colleagues in the background who can also take those questions in the background. So without further ado, I'm just going to bring up my panelist biography. So forgive me if I'm staring very hard at the screen while reading out some of the background. So first of all, we have with us Peter Ho. So Peter Ho has been with us many of our events for a large number of years. He is very, very supportive. And so Peter is the co-founder and also CEO of Hope Technique. Now, Hope Technique is a homegrown engineering business that focuses in the past focused quite a bit on really the hardcore engineering aspects of mechanical engineering, and they produced the red rhinos that the Singapore Civil Defence Force use in firefighting. That's one of the highlights. But more recently they worked with Airbus and so on, where you will find that they are engaging with a whole range of companies, both local and overseas as well. And in fact, they were highlighted for being one of the SMEs in Singapore that really have the capability to bring Singapore into the future. So they're not your typical SMEs, which you might think of with a Chinese boss, and that sort of clan connections. So we'll leave Peter to talk about his company a little bit later. Then the second panelist that we have with us is Leroy Xiao. So he also graduated. All our speakers are alumni, okay? So he has been with Procter & Gamble for quite a while already, and he is now the country manager for P&G. And he has also lived in several countries around the region. And, as the economy is now focusing on Asia, and in particular Southeast Asia, I think Leroy will be a very important voice in speaking about opportunities close to us around the region. So third, we have Gary Wong, who is with DSTA. I know for many of our ME students, DSTA is one of those dream for Singaporean students, is one of those dream companies, because you think you'll be inventing stealth weapons and so on. So anyway, Gary is the head of capability development in DSTA, Defence Science and Technology Agency of Singapore, and he is overseeing the capability development of tracked vehicles and combat engineering systems. So yes, there you go, combat. So Gary has supervised and guided, program managers in DSTA for the acquisition and upgrade of track platforms, such as the 2SG main battle tank, and also the, the Bionics armored fighting vehicle, which I think many might be familiar with. So Gary has more than 15 years of experience in management in both tracked and wheeled platforms, and was also the lead as program manager for our M3G amphibious float bridge, which probably some of you going through NS or been through NS would have known about. Also the Terex infantry carrier vehicle and the Trailblazer countermine vehicles, which all sound very, very awesome. So you can ask questions of him later. Then last but certainly not the least, a woman like myself, in mechanical engineering, somewhat rare, but not, completely rare. There are talking about women in engineering in our ME undergraduate program, we have about, close to 20% of women. That has actually doubled since the time I was doing ME, and probably the same with Siu Ping as well. So anyway, Wan Siu Ping is also our alumna, and she is currently the senior consultant for complex equipment design, automation, and supplier development at the Precision Engineering Center of Innovation at SIMTech. So SIMTech is one of our A-star institutes that work very closely with industry, on equipment and automation and technology. So she actually co-founded a startup for the semiconductor industry, and she has been working in a research environment for more than a decade, also offering consultancy services and so on. So if you want to know what a mechanical engineer is doing in semiconductors, I think I'm going to leave Siu Ping to talk about that later. And also, Siu Ping, she actually has several degrees in master's degree, and also she's very involved with the Institution of Engineers Singapore, as well as the Singapore Industrial Automation Association. So that's enough from me. So I'm going to invite the panelists one by one to talk a little bit about themselves, and then feel free, please, to ask questions in the Q&A chat that you can see on your screen. So I'm going to invite Peter first to talk about Hope Technic and a little bit about your background. So Peter, please take it away.
Thank you very much, Prof. Nice to see you again, and thanks for having me on board, everyone. So my name is Peter. I'm one of the 4 co-founders of Hope Technic. We are an engineering company here in Singapore. We are the engineers, right? In the sense that we just like to build stuff. And that's our only obsession altogether. We do mechanical, electrical, software engineering, and we are very diversified. So we have one division, Technique Square, which is doing special projects. That means anything that's not readily available off the shelf, whether it's a tiny robot for laparoscopy or a space plane demonstrator, or to a capsule that can send someone to lower space. We've done that. We have another division, Trigen, Automotive, which does emergency vehicles. Like Prof. Lim mentioned just now, that's the very visible one would be the Red Rhino fire trucks. But believe it or not, the command vehicles in Seoul, in Busan, fire trucks in Indonesia, in Philippines, Cebu Airport, in Macau. We've got I think we've got almost 1,000 vehicles running around somewhere in the world. So that's our vehicle arm. We have got a software division that does a middleware for all of healthcare. So basically, devices and robots in hospitals come from different brands and stuff like that. And we created a middleware such that they can all intercommunicate and fleet manage it. And I guess the funniest one, which you all will find unusual, is that we became farmers. So we've got a joint venture where we have built the world's first fully automated vegetable farm, from sowing the seeds to transplanting, to harvesting, to packaging, to weighing the vegetables, to washing the pots and washing the tray. So by the end of this year, we'll be doing around 2,000 kilograms of xiao bai cai a day using 4 persons. So yeah, that's the whole thing. So what's common about it all is actually we're in the business of building things that move, or any part of even our software engineering is all about movement. So I guess being a mechanical engineer alumni from NUS, right? It's very close to heart. We think that it's the art of movement. There is a lot of physics involved in it. There's a lot of uncertainty when things move. And in the software world, when you say A equals to B, A equals to B. Well, in the physical world, A can be anything that you think it might be. And I'm very sure Gary later will tell you the bigger challenges when the platforms get larger of what we all deal with. So yeah, in a nutshell, that's who I am, and that's the company I work for.
Wonderful, Peter. I didn't know about the vegetable, and I imagine that in the future going ahead is going to be very important, food security and being able to automate that without much people. So anyway, we'll speak more to you again later, Peter. So let's move on to our next panelist, Leroy Xiao, and please tell us a little bit about yourself and maybe your experiences with Southeast Asia.
Sure. Thanks, Prof. Lim. I think also I saw Prof. Sia and Prof. Teo, in the call. So hello, hi. Not seen you guys for a long time. So yeah, a little bit about myself. I'm Leroy. I actually graduated in 2004. I've been working in, so I'm married with 3 kids now, right? Big kids now. I've been in Procter & Gamble now 16 years. So Procter & Gamble, a lot of you might not know the company, but we actually manufacture and distribute products like Pantene, Gillette, Oral-B, Pampers, Olay, SK2, even some pharmaceutical product like Vicks, Neurobion, Sangobion. So yeah, I'm in the business of cleaning people, cleaning clothes. We also do Dynamo, Downy, Fab. So I'm sure I hope I have some of these products in every single of your household because that's what pays me. So yeah, so I'm actually pretty glad to be part of this panel because I would like to share that I work in American MNCs. I started in Singapore. Basically, my first job in P&G was to go to a supermarket to stock up product onto the shelf. That was what I did in my first 6 months, right? I go to the supermarket, talk to the aunties, and auntie, can you help me order some Pampers and some Pantene so that I can put it on the shelf for hopefully when the panic buying comes, you guys have product to buy. I've actually had the opportunity to leave out of Singapore 4 times. I've been in the company now 16 years. I actually worked only in Singapore for about 5 years. So I've lived and worked in Malaysia twice. I'm actually now physically in Malaysia. I've lived and worked in Thailand twice, and I've lived and worked in Indonesia once. So I think like what Prof. Lim has shared, I think Asia and ASEAN are where the growth is coming from. I think if you look at it globally, the Western countries, which is the US and the Europe, are actually learning from China and Southeast Asia versus where it was 15, 16 years ago, at least in our industry. There's a lot of opportunities around this region, and I'll be more than glad to share. But I think what really got me to where I am today is really to be able to have the agility and to be able to adapt working with people from different culture. Because people in Southeast Asia, the Thai people, the Indonesian people, the Malaysian and the Singaporean, they might look the same, but when you work with them, they are all actually extremely different. That's one. The second is also, for me, when I look at myself versus my peers, the willingness to relocate and move out of Singapore, which is a very comfortable place, actually brings you a lot of learning, a lot of opportunities. And in the business that I'm working on, Singapore, we only have a 5 million population, while Indonesia has a 250 million population without 5,000 islands. So learning about supply chain, learning about distribution, learning about how to serve, 250 million consumers versus 5 million consumers in Singapore is a different ballgame. So that's what I do. That's how going to different countries has expanded my scope, given me a lot of learning. And yeah, I've been more than glad to share later. Thank you, Prof. Lim.
Thanks, Leroy. Didn't know that you were in Malaysia. Sorry, you're trapped there. Anyway, maybe let's ask Gary next to share about his experience with D-Star. We understand things are a bit hush-hush, but I'm very sure that a lot of our attendees are still very excited to hear about what you do and also the opportunities in D-Star.
Yeah, I have some slides, so I'll be sharing my screen.
Yes, go ahead, please.
Yeah. Hello everyone. I'm Gary. I'm from the Defense Science and Technology Agency. I'm from the Land System Division. So today I'll be sharing about myself, DSTA, and also some of the career opportunities that is available for the mechanical engineers. So I go on to the next slide. So DSTA, we are a state board under MINDEF. Our mission is to harness and exploit science and technology and provide technology and engineering solutions to meet the defense and security needs of Singapore. So in a very layman term, what we do is we undertake design, development, acquisition management, and also system engineering responsibilities. So our vision is to inspire people and bring innovation to all that we connect. Okay, so this also reflects our emphasis on nurturing and also motivating the staff to embrace innovation. Just a quick look at the organization chart of DSTA. You'll see many departments, but in the heart of it, actually, we have what we call the program centers. Program centers like air system, naval system, and land system. So these are the key job of the program centers are that they will deliver the solutions, the defense capabilities to the SAF. And then with that, we have the supporting entities like procurement, training, and also corporate services. Just to mention a little bit, besides the SAF, we also do quite a fair bit on whole of government. We have embedded offices, like we have we have an embedded office in the Ministry of Transport, okay, helping them with autonomous vehicle, also in the Smart Nation office, technology office. So largely, this is the organization of DSTA. Then we take a look at myself. I joined NUS like everybody when I was 21. Just to mention, let everybody know that probably in the panelists, male panelists here, last time we have served 2.5 years of NS. So joined at 21, and I actually joined DSTA at 27. I spent 6 years in NUS. It's not because I retained or whatever, but I actually did my master's in engineering full-time before I joined NUS. Started work as a project engineer. The scope of engineer will be that you will be helping the project managers and the program managers in their projects. Then at the time, up to when I was project manager, I was dealing a lot with the combat engineering systems. Those in the NS will know that these will be things like bridges, mine clearing vehicles, and also earth moving equipment. I became program manager in 33 and a senior program manager in 36 when it's my time to actually lead a program. So as mentioned by Prof. Lim earlier, some of the more notable programs that I've done, Terex 8x8 vehicle, the M3G amphibious float bridge. If you don't know what is this, it is the platform that we put our parade ceremony gun and fire off on the Marina Barrage. What is at 40, I was actually sent to MINDEF. I say that I mentioned earlier that we do have some embedded office. There's one in MINDEF also. I was kept dev consultant. This is actually to promote what we call ops stack integration. That means we will need to know more about what the ops is doing, okay, a better understanding so that it help our job. Current role is head capability development. So what I do is I guide a team of senior program managers in the area of track vehicles. Track vehicles meaning vehicles that are running on track, like your main battle tanks, your armor fighting vehicles, and also your combat service vehicles. So that is about me. Then we go on to what we can offer. In DSTA, what we offer is we offer scholarships, we all do internships, and also, of course, lastly is careers. For today's sharing, I'll talk more about internship and career. For internship, when you do an internship, you're looking at what we have, what you looking at an immersive program experience and hands-on opportunities on accepting multidisciplinary engineering work. What I normally do is that I will, the mentor will probably be a senior program manager or program manager, and he'll work with me that we'll tailor something that will be exciting for you, but also help in a certain part of the project. So this is the part on the internship. For careers in DSTA, what we're looking at, the key features that we have that is of DSTA, working in DSTA is first that we have a very nurturing environment and comprehensive self-development program. We are a big organization and we even have our own DSTA college that customize courses to train our own people. Perhaps what I forgot to mention is that on my earlier slide, when you see that before you become a project manager or program manager, there are certain courses, okay, in-house courses that you need to attend before you can become take up the appointment. So that is the part on a nurturing environment. Every staff will have a personalized career development plan. We look at what you want to do in the near term and the long term, and then we try to fit you on the course. We are a very creative and dynamic environment, very open feedback culture. We have a lot of heart-to-heart, one-to-one talk. There's even a 360 feedback session. Lastly, this one is a lot of people are very concerned is about remuneration. Okay, we are very competitive. We benchmark our salary with the industry regularly, and this is probably what I have. Okay, last part will be how to keep in touch with us. You can go to our website. We are on Facebook, Instagram, and we also have our website at dsta.gov.sg. Okay, that's all I have.
Thanks, Gary. I think, as I said, a lot of Singaporean students actually find that DSTA is one of their dream jobs. So I'm very glad you talked about, internships and careers. Last we have Shu Ping with us, who as I mentioned, started up a semiconductors startup. So maybe Shu Ping, you just want to go ahead and tell us a little bit about your background and how you got into semiconductors.
Okay, good morning, everyone. How did I get into? When I graduated from NUS in 1982, actually I supposed to go for a DSTA interview, but somehow I skipped that because the semiconductor industry gave me opportunity just 2 weeks before. And the first day I walked into that industry, it's really amazing. It's not the normal factory that at that time in the 80s that we can imagine, because I did a so-called attachment in SBS before. I did attachment in another factory before during NUS time. So when I went to this factory, it's so different. It's so amazing because we are making small products, really small products, and everything is under the microscope. So I was there for 2 years as a process production person, engineer, looking after the process of making semiconductors. At that time in Singapore, we do not have wafer fab. We have what we call the packaging back end of wafer fab. So what we see in the factory, the input is all the wafers and how we cut up the wafers and how we make it into a chip that can go onto a PCB board. So I'm in charge of the whole process, and it was so exciting. There are so many exciting processes in there, and I can relate what I learned from NUS during the 3-4 years after first year. From second year onwards, you really get into a lot of engineering details, engineering subjects, and every single subject that I had attended actually helped me in the process to understand what is happening. And this industry at that time was really very manual. The production that I'm in charge of has got 1,000 people per shift. And we have to answer to a lot of, throughput issues and all that every day. And for challenging a new engineer in the whole production floor, actually we found that, or rather me and my colleagues, we found that there are a lot of challenges in controlling quality through operators. So from there, we actually started to do our internal in-house improvement plan. And that's where it started us on automation, and a team of us, about 10, we started the startup after 2 years. For me, it's after 2 years in the company, we all came up to do startup. And our startup is focused to build automated equipment to solve the real manufacturing problem. So from there, our team, we learned how to do, from a blank concept, no machine concept, but you come up with a machine concept, and put in all the latest electronics control, and then we have automated equipment. So from there on, our little startup gone on to do automation, not only for the Singapore factories, we also go on to Malaysia, we expanded to Philippines, Thailand, and eventually even we sell machines to the US. So that's how we grow. And the challenging thing is that at that time, even we came back to NUS or went to NTU to look for help, because we are working on, as we progress along with the semicon industry changes, so we actually hit onto a lot of technology barrier. So we need to buy technology, and at one time we go around the world to buy technology from Europe, from US and all that to put into our automation. And we work together with all these European companies, US companies to come out with latest technology that the industry needs. So our work is very much really designed up and using engineering knowledge. And we get to really see the world, because as many of our panelists say, Singapore is so small, we can count the number of machines we can sell. So we definitely have to sell to Malaysia, to Thailand, to Philippines, Taiwan. In fact, I spent many months in Malaysia and many months in Taiwan, serving our Taiwanese and Malaysian customer. And all our people have chance, especially engineers level, have chance to travel and expose ourselves to new opportunities, learn from people from overseas, how they run the factory, what are the technology level, and what are the new things they are working on. Because in order to survive, we have to build the latest equipment that nobody has in the world, and also the fastest or the most accurate, the most precision kind of equipment. So that was a challenge for us, and we had the biggest challenge since 90s that we can't find engineering graduates to fit the job. So since the 90s, we have been taking a lot of interns. Every year, guaranteed we'll take interns from the universities or the local polytechnics. And internship, from my experience, is really very good, because even if it's 6 weeks or 8 weeks at that time, we managed to, when we take 5 interns or 6 interns, we managed to keep about 50% of them and groom them to be our future leaders in our design. And also very happy to see quite a lot of them now at the current moment are young startup, like people like Hope Technique, that kind of a young startup with latest technology that they are pursuing. So I think really this internship, I really think that we should work hard on it. But then after the 90s, there was a period where all the schools doesn't offer internship. So we had a hard time, but then we managed to get foreign engineers, and we also have a very good chance to work with people from diverse background. Okay, semicon is a very global industry. So when my first job, I walked into a semicon factory in Singapore. My boss is Taiwanese. My direct boss is, my department boss is Taiwanese. My direct boss is from Malaysia. The rest of the colleague, almost 80% are from different parts of Southeast Asia. Okay, and the big boss definitely from US. So there is this environment that you really learn different cultures and how we work together. And when we go travel to our different customer location, we also learned how to work with the customer there. Even though we are all in semicon industry, different companies has different way of running it. and there's a very challenging, and this industry is always very challenging, and that's why maybe some of our engineers or graduate engineers cannot take the stress. And but then in our company, my ex-company, we do not, if people come in, they want to be engineer in different sector, different roles, like you can be a design engineer, you can be a service engineer, you can be assembly, manufacturing, operation engineer. We will match them. And to our many years of trial with engineers, mechanical engineers is the people who are normally who can become leaders of equipment design, equipment system, equipment manufacturing. Even the mechanical engineers normally are the better ones for the service when we go to meet customer, solve application problem, or on the ground solve the service installation issues. I'm not saying the other double E is not important. The double E is the other most important engineers we are looking at. But then mechanical engineer normally can, like what I think Peter mentioned, or one of the speaker mentioned, we have a few of real things, realistic, when from design, from theory, from CAD drawing, whatever, we have a few, we can relate to the physical, real happening. Even for software, my company experience is that we tried IT people from computer science training because we shortage of engineers, no choice, we tried. But then that training, the engineers cannot imagine when the machine has a crash and it crash in front of their eyes and they cannot feel it at all. So there's a total, we find, it's not only one person, we tried more than one person, and we have the same, observation. So in the end, it's still, we must train engineering graduate to do software, and to know how to prevent, software also must prevent safety issues, accidents and things like that. So it was a very exciting many years that I spent with all my different engineers that we had. And the interesting thing to point out also, Christine, my department, my small startup when we started, we do not have too many ladies, only, I would say 4 ladies engineers, 2 on software and 2 on mechanical design. But as we grow to about 100, we found that actually we tend to have more ladies engineers doing design, okay? And maybe they are more prone to able to sit down and look at all the details, okay? That's one. But when we come to a total project, well, we have very good guys engineers who like to travel around. And I always tell my engineers, if you don't like design, don't mind, you can travel, because we need people to travel, find the customer, settle the customer problem aside. So with a mechanical engineering background, the engineers can fit into many different types of jobs. And the most important, we also found in the long term, is that even the sales job, sales must be engineer background, okay? Even the procurement person in our kind of industry must be engineer's background, okay?
Thanks.
Yes, maybe that's all.
Yes, thank you. Thank you. I think Xiu Ping made a very important point about the versatility of our training. And in fact, for those of you who are joining us in the next year, we have a new curriculum which has things like design thinking. So, even the men can be well trained in that. And project management, also a very important skill, even systems thinking. So these are the new curriculum that we're introducing to all engineering students. So I think, we increasingly, I think our industry speakers have pointed out very clearly that these are actually, skills that are needed in the job. Now, quickly, we're going to get to the questions. I'm actually going to address this question to both Peter as well as Gary. And this question, the number of related questions basically involves aeronautical specialization. We know that boys like their planes, and aeronautical specialization has always been, one of the most sought after specializations in ME. But, with the current COVID situation, I think it's the first time in aviation history that you see such a huge drop in demand. And I think people are now starting to wonder, is it still good to pursue my passion in planes? Are there going to be opportunities for me to work in there? Even given the downturn and the fact that things can turn around, can actually turn sour overnight. So maybe let me ask Peter first, and then I'll ask Gary about, whether students with aeronautical specialization will be negatively impacted. Peter?
No. It's a short blip, I hope, COVID. If you look at it, it's not just aeronautical engineering, oil and gas is also suffering. There are several sectors out there which are victims of this terrible pandemic we're in. But, once air travel reopens, which we really all hope it's going to be soon, it's going to be business as usual. So don't worry about a short-term problem. The market will change and the focus will move. If you look at it 10 years ago, 20 years ago, computer science was not very attractive, but right now it's the hottest form out there per se. But just follow what you really are interested in doing, and there will always be an industry that will exist.
Thanks, Peter. So Gary, I think DSTA is one of those rare places where, and maybe ST engineering, where our students get to design things that fly. So would you like to say something about, students with aeronautical specialization background? Will they be able to design things like I think?
First, I just want to say that I totally agree with what Peter said. This COVID affecting the aeronautical industry will be a short one. How long, we do not know, but I think everybody is still looking forward to going overseas for holiday, probably next year or end of the year kind of thing. So do not be affected by what is happening now. When you look into a career, you're looking at something that is long-term. Aeroplanes are going to continue flying for a very, very long time. I do not see any other forms of air travel, new forms of air travel that will make aeronautical engineering obsolete. Perhaps the other one, whether you ask me if the design work and kind of thing in DSTA, what we do, there's one question that was actually asked, that whether is it more office work or more hands-on. I would say it also depends on which phase the project is in, because like I mentioned in my slide earlier, we do the acquisition management of it. It could be different phases. If you are doing the let's say the contracting, the market survey, there could be quite a lot of overseas work, overseas opportunities that you'll be going there to look at the thing, look at the test the performance, and then there will also be probably some phase of the project which needs to be in office, like during the tendering and doing the evaluation kind of part. But eventually, during the delivery phase of project, you could be looking at depends on where is the system board. You're looking at probably a good 50% of both office and hands-on work. We don't really build the platforms like what Hope Technic or Peter they are doing, but of course we are very involved in the design, also the testing and the qualification of the systems.
Gary, just a related question, because I see this, one of the earlier questions is, do you need professional engineers registration to work on, air systems in the STA, for example?
No, I don't think you don't need to. Probably later in the career, it's always good to have it.
Okay, great. Thanks, Gary and Peter. Leroy, I want to turn to a different aspect, and it actually relates to what Xu Ping was talking about. So Xu Ping said ME engineers actually, make one of the best employees. And, you are not working so much on the hardcore technology as the rest of our panelists. So maybe you want to share with us, did you think that your mechanical engineering background actually helped you in your current job, over the last more than a decade? And you know, mechanical engineering students be able to actually come into the kind of work that you're doing?
Yep, Prof. Krishna, I think thanks for asking. I think it's a very important question because I'm probably the only one who's not really using the knowledge that I've learned in 4 years in NUS in my current job. But if I just take a look back at you know, what I've done in mechanical engineer, you know, there are things that I do that are definitely very relevant. For example, you know, when we need to do a project, right, you need to do project management. And as part of project management, you need to get the right people into your team, right? And maybe some of us unknowingly, we actually need to do marketing and sales for our project also, because we need to present to the professors, present to the team on why our project is so great. We need to sell our product, right? Why our, you know, the machine that we build or the cars that we build, you know, is it the best, is it the fastest? So I think there's a certain aspect of, you know, marketing and sales there as well. And I also think, you know, problem solving is a skill set that we pick up in mechanical engineering. I think like what Siu Ping has mentioned, right? Because in our job, it's really about solving everyday's problem, right? You'll be amazed at the types of problems that we need to solve, selling shampoos and and detergent to the world. The other one is really logic and how you develop systems and processes, right, to run a big business. I think there is another part. I mean, it might not come from a core knowledge and hard skill that the mechanical engineer gives me, but I think throughout the courses, as you go through the modules, as you take part in all the projects, the final year project that I work with Prof. Teo, right, the multiple discussions that I have with him where he gives me advices, I think, you know, in my initial startup in P&G, it was actually extremely helpful. Yeah.
Thanks, Leroy. You know, talking about selling stuff, I want to direct the next question actually to Peter, because, you know, Hope Technique being started from an unknown, and I'm sure that there was a lot of selling and marketing involved. And so, Peter, you know, besides the engineers that you hire having to have good technical skills, you know, what are the other skills that you might be looking for when you consider hiring engineers into your company?
First and foremost, I think we've been very fortunate throughout our entire journey that a lot of local agencies and companies have given us the opportunity. I mean, effectively after this call, Gary returns to being my boss, right? We always wait to see what offerings he'll give, send in our direction. But soft skills, technical, non-technical is necessary. I mean, the world is very complicated. First and foremost, you must technically be good. You can't run away from it. In the engineering world, you can't bluff your way out of it. Bridges will fall, planes will fall out of the sky, and cars won't move. Okay, cannot lie to yourself on that. But other than that, right? First and foremost, you have to deal with other people. You need to communicate your ideas per se. So all the soft skills, as engineers, you know, I can be candid with you, we resent them. That's what arts and social science is supposed to be for. But the reality is that you need to embrace it. You need to be good at it. I could put it as a simple way. If you look at a Venn diagram, those circly diagrams, right? If you are very good in only one area, that's you fight against the rest of the world. If you're good in two different areas where the two circles coincide, then you become a little bit more unique and marketable as an individual. And so that's exactly what it needs to be technical as well as having the soft skills. So yeah, you don't try and have all of them. Don't try and kill yourself on that. But it is necessary to have that balance.
Thanks, Peter. I actually have a question for Siu Ping, but we'll come to that later. But before that, I want to continue this discussion on soft skills with Gary. You know, Gary, as I mentioned just now, our new curriculum has things like design thinking, you know, project management, systems thinking, artificial intelligence. You know, because you have been in DSTA working your way to management now and for a number of years, do you think that these kind of modules actually help our graduates become better engineers? And, you know, will they fit better into the DSTA system if, you know, they can think better in terms of design or systems and project management? So maybe you can comment on that.
I share recently over the year, the past recent years, we also adopt design thinking in DSTA. So it is basically an approach that how you're going to solve problems, user empathy, or this kind of thing. I must say that my training as a mechanical engineer is multidiscipline, is a very systematic way of how you solve problems. So when you go to do, when I took out a course on design innovation, actually I felt that over the years, you are really systematically already doing part of it. It's just that the course, you know, is you put it notes, they have pointers and what. So you find that, oh yeah, actually all this I've been doing it is okay. I know how to do this, but the course comes first. So this is definitely going to help. And if you look at project management, like in DSTA, actually we are multidisciplinary. We need people that is well versed in a lot of areas. Okay, so sometimes you can say jack all trade, a master of none. Okay, but we really need people that are multidisciplinary. So mechanical engineers actually do fit quite well in the job. And when you do project management, you actually probably, because of your training and because of your knowledge, everything you know a little bit, those that you need to know more, you just have to do some more training or do some more experience with it. You can easily handle the job. So that's all I have to say. Yeah.
Thanks, Gary.
Yeah.
Yeah, the curriculum has actually changed a lot from when we were students, I think. So Xiu Ping, I have kept the last question for you. We are running into the noon time. So my question actually for you is, as a woman engineer, I think very often parents in particular are concerned, you know, parents who are not trained in engineering are concerned about their daughters taking up engineering because of an image issue or the fact that maybe they can't cope as well. So, you know, Xiu Ping, you have been in engineering all this time and you have been actually at the frontier of many things for women engineers. So maybe share some experiences about what it is like to be a woman engineer in sort of like a men's world, especially in mechanical engineering. And would you encourage girls who are interested in, you know, science and math and, you know, really solving problems to go into engineering without fear?
Okay. I think, Christine, I think you mentioned something, the first part of what you speak just now was about if the parents are not from engineering background, they cannot understand. Yes, I think that part is one key hurdle. And I'm lucky enough that it's not just my parents, it's not in engineering background. Or rather, my family history is in engineering background. Okay, so technically per se, by right, that should not be hurdle. But by left, that is the biggest hurdle because my grandfather did put it in, you know, in the olden days when you're from engineering background, all these skill sets are transmitted or rather passed down to the guys in the family through apprenticeship. Okay, not to school, but through apprenticeship. So when I was very young, he already complained that, you know, I have a granddaughter who is not a guy, is a lady. So actually has been, you know, having this hurdle that why should you be in engineering? And actually there's many hurdles, but somehow maybe I'm fated to be in engineering. I passed all the tests and all, I managed to go to U. I'm not supposed to go to U in the first place, but I managed to get in. So I was a self-funded student. And at that time when I graduate, that's why when DSTA come and offer an interview, that was later. So actually before that, my parents saying, you must get other jobs, go and do other jobs, do teaching, do whatever. Okay. And even you graduate, maybe you go and work in MOE, you know, that kind of thing. a polytechnic, but somehow I didn't get all those offers. I got a job offer in a factory. And of course, the biggest hurdle will be the parents' concern is what is the factory doing? How come the factory is not in Jurong, but it's in Toa Payoh? Okay, so this kind of details, they go and question. But after I enter the factory, I see that who are in the factory? Almost 90% ladies. Why? Because they are the very patient operators who can do the wire bonding with a steady hand and a sharp eye. Okay, in fact, the whole production floor, beside the management, a lot of more men, but still have ladies. The rest are all ladies. So maybe I'm lucky to get into that sector. So you don't really feel that much. But when we come to really working, there's no difference, because maybe my colleagues at that time, they are less graduate in the production floor. So we can manage to answer all the questions from the US and all those things that we learn in school, we can use. So that is where I think the overall society actually don't they don't put a hurdle to you except that whether you can do the job. So that's what I find. Okay, and I just want to add to just now the earliest panelists when they talk about aerospace. Okay, from my industry or my experience operating this automation company, actually what we found out is that especially semicon industry is even worse than aerospace. Our industry is, because it's at the forefront of new technology, right? So the chips design has been changing, and from 1960s onwards, there was always a cycle. After 5 years, 6 years, it always up and down. And since the 80s, the cycle goes shorter and shorter because the product has been changing and changing, just like handphone, computers. So once all this business change, the demand of manpower in the industry go up and down because the business changes. So over the years, there are a lot of people say, oh yeah, electronics industry, bad time, I will run to other industry. I think it's fine. But those people who stay are those people who have certain skill set that is still needed. So aerospace, people who study aerospace or in school or what, it doesn't mean that aerospace industry down, you don't have a job, because what you learn in aerodynamics, what you learn in all the rest of mechanical engineering, even technical drawing, the basic skill to enter our design industry is technical drawing. So if you don't have skill set of technical drawing, that is some skill that you must learn before you have an easy entry into the industry. Because without that, you don't understand what people are exchanging in all the design through the drawings. So I would say all under people who want to take engineering, doesn't matter which industry, you take aerospace now, you'll be very good at aerodynamics. You can come out, and now we're having a lot of people designing special fan. Okay, a normal fan that we see every day, but they have to improve for better and better. And fan is not only for the home, it's also for a lot of buildings, it's also for marine, right? So if you learn certain skill set in aerospace specialty, it's not lost. And other fundamentals like materials, how to apply, like Prof. Sia teach us last time about polymers and all that. So all these are important things you learn in mechanical engineering that will help you sometime in your job. Doesn't matter. In fact, why Simta had this precision engineering? Actually, precision engineering is a fundamental, it's just fundamental engineering skills that, basically mechanical in nature, okay, that applies to all industry, aerospace, marine, building, a lot of other things that we learn under structures, right? So it's just that for semicon industry, we are very, we go from machinery that you need to make very big items, machining of very big items, precision machining, all these, the design is very similar to the big items. Of course, it's a smaller scale, but it's still similar precision details like what you learn in aerospace. So actually, to me, mechanical engineering is mechanical engineering. Which specialty you take, you will sure find an industry that you can fit later. because we took so many subjects, right? That's what I think. The many is the important thing. Okay.
Right. Thanks so much to all our panelists and for the wisdom. And I think, you know, our panelists here, they get up every morning, and I think that you can see that they're excited about their jobs. And so they come from, you know, they've ended up in a whole range of different fields. And so I would encourage those of you who really are interested in, you know, math and science, and not just finding out, loving how things work, but also trying to use technology to make a difference, even when it's coming to things like marketing of products and so on, to seriously consider engineering. So I want to thank our panelists who really took their very precious time to spend with us this morning. Thank you to our audience as well. We have an engineering open house. Unfortunately, it's all online. So Engineering Open House is on the 15th of May. So it's happening 2 Saturdays from today. Is that 2 Saturdays or next Saturday? Anyway, 15th of May. So you will be able to get another opportunity to ask your questions, mainly on curriculum, but we will get our students with us to answer questions as well. They're having, at the end of their exams, they will come and join us on the 15th. So you can ask your senior, you know, more about student life and whether what they think about the current curriculum that they're undergoing. So thank you all, both panelists as well as the attendees all. Thank you very much. Have a good lunch, and, you know, we'll see you again sometime. Thank you so much. Bye, everyone.
Thank you for the time. Yeah.
Bye.
Bye-bye.
Thank you. Thank you.